Line has equation y equals 2x plus 6. Show that 312 lies on the line. Okay, so to show that a point lies on a line or any other function, we substitute either both x and y coordinates into the function, or we can just substitute one or the other. If we get the corresponding coordinate from the point, then the point lies on that line. So what that means, okay, we are going to substitute x equals 3. Or if after substituting x equals 3, our y value is 12, which is the y coordinate of the point, then that point lies on the line. So y equals 2 times 3 plus 6. 6 plus 6 equals 12. So therefore, 312 lies on the line y equals 2x plus 6. It's not part of the question, but let's just substitute any other point. Let's put minus 3, 2. Let's see if minus 3, 2 lies on the line. So if x equals minus 3, then y equals 2 times minus 3 plus 6. Minus 6 plus 6 equals 0. Now, because 0 is not 2, we will say, therefore, minus 3, 2 does not lie on y equals 2x plus 6. What is the gradient of the line? Well, the gradient of the line is just, once the line is in standard form, which it is, the gradient of the line is just the coefficient of x. So the gradient equals 2. C, draw a graph of the line. Okay, so use the table method or the dual intercept method, whichever method you choose. Find the equation of a line parallel to y equals 2x plus 6, but through the origin. Okay, so this line is y equals 2x plus 6. That's the line that we sketched in part C. We now need to find the equation of a line that is parallel to this line, but passes through the origin. So the origin is the point 0, 0. So the line has to go through 0, 0 and be parallel to this line. So we know that for parallel lines, the gradients are equal, right? So the line that we're looking for, if you just call this line 1, then line 2 will be y equals mx plus c, the equation, the general equation of a straight line. The gradient of line 2 must be the same as the gradient of line 1. So that's the definition of parallel lines, is that their gradients are equal. So y equals 2x plus c. Now, this line, line 2, has to pass through the origin, which means it has to go through the point 0, 0. So we substitute x and y into this line. So 0 equals 2 times 0 plus c. 0 equals 0 plus c. In other words, c equals 0. So line 2 is y equals 2x plus 0, which we don't write the plus 0, we just write y equals 2x. And by sketching y equals 2x, we can clearly see that the lines are parallel. They're parallel because they have equal gradients. And find the equation of a line parallel to y equals 2x plus 6, but passing through the point 0, 3. So without doing it algebraically, the third line, it says it needs to pass through the point 0, 3. So the y-intercept is 3. So the line is going to pass through where y equals 3, which is at that point there. And the line is going to be parallel to both of these lines because they have the same gradient. So line 3, y equals mx plus c, it will have the same gradient as y equals 2x plus 1, line 1. So y will equal 2x plus c, and it has to pass through the point 0, 3. So x is 0, y is 3. 3 equals 2 times 0 plus c. 3 equals 0 plus c. C equals 3. So line 3 will have the equation y equals 2x plus 3. And again, we can sketch the line on the same set of axes, and we can see that all three of these lines are parallel to each other because all three of them have got the same gradient of 2. The line has the equation y equals a quarter x minus 4. Find the coordinates of the points where the line crosses the y-axis and the x-axis. In other words, they're asking us for the intercepts with the axes. And then find the equation of a line that is parallel to the given line that passes through the point 8, 5. Okay, so y equals a quarter x minus 1. To find the y-intercept and the x-intercept, we're going to use the dual intercept method. So the x-intercept is when y equals 0. So 0 equals a quarter x minus 1. And now we solve for x. A quarter x equals 1. Multiply both sides by 4. X equals 4. So therefore, let's call it point A. The x-intercept is A. The x-coordinate first, which is 4, and y equals 0. So the x-intercept is the point A, 4, 0. The y-intercept, we put x equal to 0. So y equals a quarter times 0 minus 1. Y equals 0 minus 1. Y is minus 1. We call this point B. X-coordinate first, which is 0. And then the y-coordinate, minus 1. B is the y-intercept, which has coordinates 0, minus 1. Okay, I find the equation of a line that's parallel to this line y equals a quarter x minus 1, but passes through 8, 5. So the line we want is y equals mx plus c. This line, I'm going to call that line 2. And this is line 1. Line 1 has to be parallel to line 2. Or line 2 has to be parallel to line 1. So therefore, the gradient of line 2 has to be the same as the gradient of line 1, which is a quarter. So y equals a quarter x plus c. This line 2 passes through that point 8, 5. So x is 8 and y equals 5. So 5 equals a quarter times 8 plus c. Quarter times 8 is 2. 5 equals 2 plus c. So therefore c equals 3. So line 2 is therefore has the equation y equals a quarter x plus 3. Question 3. A line has equation y equals 8 minus 2x. What is the gradient of this line? Okay, first of all, this is not written in standard form. It's not written in the form that you're used to seeing, y equals mx plus c. This is standard form. Always write a straight line function graph in standard form. Any function for that matter should be in standard form. So y equals minus 2x plus 8. This is now in standard form. The gradient of this line is the coefficient of x, which is that. So the gradient equals minus 2. Okay, where does the line cross the x-axis? Okay, so the line is y equals, in standard form, minus 2x plus 8. Where does the line cross the x-axis? They're asking us for the x-intercept. So we put y equal to 0. So 0 equals minus 2x plus 8, and we solve for x. 2x equals 8, divided by 2x equals 4. So the point where the line crosses the x-axis is the point 4, 0. Remember, it's x coordinate first and then the y coordinate. X is 4, y equals 0. And now required to draw the line on a grid. So we've sketched the line, y equals minus 2x plus 8. You can either use the table method or the dual intercept method. Parallel line passes through the origin. What is the equation? Okay, so the function we have, the line we have is y equals minus 2x plus 8. We're talking about a line that is parallel, which means the gradient is the same. So the second line, so this will be line 1, and then line 2, y will be minus 2x plus c, because parallel lines have got equal gradients, and the gradient of the first line is minus 2. So the gradient of the second line is also minus 2. Now, this parallel line, the second line, passes through the origin. That means it goes through the point 0, 0. So the x-coordinate is 0 and the y-coordinate is 0. So 0 equals minus 2 times 0 plus c. 0 equals 0 plus c. c is 0. So the second line is y equals minus 2x. E. Find the equation of a line that is parallel to line 1 and passes through 5, 4. So line 3 will have the same gradient, so y equals minus 2x plus c. Okay, parallel lines have got equal gradients. That's how we know that m equals minus 2 for line 3. Line 3 passes to the point 5, 4, so the x value, the x coordinate is 5, the y coordinate is 4. So 4 equals minus 2 times 5 plus c. 4 equals minus 10 plus c. Take minus 10 across, c equals 14. So line 3 is the line y equals minus 2x plus 14. Question 4. The line with the equation y equals 5x plus k passes through the point 211. Find the value of k. Okay, so y equals 5x plus k passes through the point 211. The x-coordinate is 2, the y-coordinate is 11. So we substitute this point into the line. So 11 equals 5 times 2 plus k. 11 equals 10 plus k. K equals 1. So the line is y equals 5x plus 1. B, a line that is parallel to the line in part A. So we'll just call this line 1 so we can refer to it. So a line that is parallel to line 1 passes through 411. Find the equation of this line. So for line 2, it's parallel, which means the gradient is the same. The gradient of line 1 is 5. So the gradient of line 2 is also 5. So y equals 5x plus c. This is the gradient of line 2. Now line 2 passes through the point 411. So the x-coordinate is 4, the y-coordinate is 11, and we substitute that point into the line. So 11 equals 5 times 4 plus c. 11 equals 20 plus c. c equals minus 9. So line 3 is given by y equals 5x minus 9.